In this online session, we're going to learn two different models. The first is called a cross-median approach. We use cross-median approach to identify the best location to serve multiple customer areas. The second model we're going to learn is called Hub model. So we use Hub model to calculate the market share when there are multiple stores. So how much market share each store can capture. So first of all, let's look at cross-median approach. With a cross-median approach, it can be used to locate a single facility on a plane to minimize the total travel distance to serve multiple locations. So when you have multiple locations or multiple customer areas, so for example, multiple communities or multiple cities, you want to build a single facility to serve these multiple cities or multiple communities. How do you choose the best location? We want to choose a location to minimize the total travel distance for all the people who live in these areas. So here, to simplify things, we measure distance by metropolitan matrix. So cross-median approach, we need to do 3 steps. The first step, so first of all, I will go over all 3 steps, and then we'll look at one specific example. So first, step 1, we calculate the median value of the weights for all customer locations. So what are the weights? So when we talk about cross-median approach, for each city or community, we have weights. So typically, for most cases, we can view weights as population. So if you're serving 5 customer locations, not all 5 locations are equally important. Some locations larger than other locations. So how do we measure it? We use weights. So most cases, we can view weights as a custom population. So if one particular city or one particular community has more population, that means we have to give it more weights. You have to consider this is a more important location. So this is the first one. Calculate median value. I'll talk about when we go to the first example. We'll talk about how to calculate the median value for all the weights. Step 2 is about to identify the x-coordinate value for the single facility. So here we want to identify the best location for this single facility. So how do we identify the best location for the single facility? We need to identify the x-coordinate, and also we need to identify the y-coordinate. So we need 2 values. So once we know x and y, we know the location for the single facility. So how do we view x and y? We can view x and y as a longitude and latitude. So this is step 2. So for step 2, we want to identify x-coordinate value for a single location. For step 2, it also includes 3 sub-steps. So first of all, going from west to east, you look at the map. Going from west to east, look at the sequence of these different customer locations. Keep adding the weights of each location. So going from west to east, keep adding the weights for all these locations until the total reaches or exceeds the median value identified in step 1. Then we mark the last location. So going from west to east, we keep adding weights. When the total weight exceeds or reaches the median value identified in step 1, we mark the last location. Step 2.2, very similar, but direction is different. We go from east to west, the opposite. So going from east to west, we keep adding the weights of each location until the total reaches or exceeds the median value identified in step 1, then we mark the last location. So by doing 2.1, 2.2, we basically mark 2 locations, either last location in 2.1, the last location in 2.2. Then we do step 2.3. If the locations marked in 2.1 and 2.2 are the same, if they are the same, then the x-coordinate of the facility equals the x-coordinate of this location because they are the same. On the other hand, if the 2 locations identified in step 2.1 and step 2.2 are not the same, they're not the same, then the x-coordinate of the facility can be anywhere between the 2 locations identified in step 2.1, 2.2. So this is about how to identify the x-coordinate value for a single location. So step 3 is about identify the y-coordinated value for the single location. So it's very similar, but we're going in different directions. So in order to identify the y-coordinated value for a single location, we have to go 2 different directions. First, we go from north to south. So going from north-south, we look at all the customer locations. So keep adding the weights of each location until the total reaches or exceeds the median value identified in step 1. Then we mark the last location. Then step 3.2, so we're going from south to north, keep adding the weights of each location until the total or the sum reaches or exceeds the median value identified in step 1. Then we mark the last location as well. Once we mark these 2 locations, we move to step 3.3. We check are the 2 locations marked in step 3.1, 3.2, are they same? If they are same, then the y-coordinate of the facility equals the y-coordinate of this location because they are the same. Otherwise, if they are not the same, then the y-coordinate of the facility can be anywhere between the 2 locations identified in step 3.1 and 3.2. So this is just a procedure. So some of you may still get confused about how to do it because reading this instruction may not be super clear. So let's take a look at one specific example. So this example comes from the textbook. It's on textbook page 227, example 8.1. So here, this is the area. So in this region, we have 4 different locations. You can view these 4 different locations as a customer location or customer areas. Or you can view 4 different cities or 4 different communities. So I have city 1, city 2, city 3, and city 4. For each city, you see the weight, the W1, W2, W3, W4. The weight measures importance of that particular city. You can view weight as, for example, population. So for example, for city 1, the population is 7,000 people. For city 2, the population is 1,000 people. City 3, population 3,000 people. City 4, population is 5,000 people. So the weight measures how important each city is or each customer location is. So our objective is to build a brand new facility. We don't know where to build. We need to find out where is the best location to build a brand new facility in order to serve these 4 customer areas. So maybe somewhere here, maybe somewhere here, somewhere here, somewhere here. We don't know. So we have to follow procedure to identify the best location to serve these 4 cities. Our objective is to minimize the total travel distance for everybody. So as you can see, we are going to do 3 different steps. Okay. So in step 2 and in step 3, we are going in 4 different directions. So we said we're going to go from west to east, east to west, north to south, south to west. So what does that mean? If you look at the map, on this side, on the left-hand side, this is west. East, on the right-hand side, this is east. You think about map. This side, top is the north, bottom, south. So when I say going from west to east, we're going in this direction. West to east, going this direction. So what's the sequence? If you look at these 4 different cities, what's the sequence going from west to east? It will be city 1, then city 2, then city 3, then city 4. On the other hand, if we are going from east to west, what is the sequence of these 4 different cities? So it'll be city 4 first, then city 3, and city 2, and then city 1. What about from north to south? If you're going from north to south, going this direction to this direction, the sequence of these 4 different cities will be 3, and then 2, and then 1, and then 4. If we are going from south to north, the sequence will be 4 first, then 1, then 2, and then 3. So this is called a sequence going in 4 different directions. So when we go in each of these 4 different directions, we keep adding all these weights until the sum hits the median value. Okay, let's take a look. So step 1 is about calculate the median. Okay, how do we calculate the median? So basically what we do is that we add all the weights for all the cities and divide by 2. So be careful. Here, when we talk about median, we're not talking about average. Some people, common mistake, people do the total weights divided by 4 because they try to take an average. Don't divide by 4. Okay, if you are divide the total by 4, that means you are taking average. Here, we're not taking average, we are calculating the median value. So basically, you need to do is add all the weights for all cities. 7 plus 1 plus 3 plus 5. These are the weights for all 4 cities. And then divide by 2. Regardless of the number of cities, regardless of the number of custom locations, it's always divided by 2. Okay, keep that in mind. It's always by 2. So 7 plus 1 plus 3 plus 5 divided by 2, you get 8. So the median value is 8. So this is a very important number because in step 2 and step 3, we need to add the total weights and compare the total weights with this number, which is 8. So keep this number in your mind. Now let's do step 2. Step 2. In step 2, we need to identify the x-coordinate for the new facility. So how do we identify the x-coordinate for the new facility? We will be going in 2 different directions, from west to east, and then from east to west. Keep adding all the weights. So first of all, let's do west to east. So going from west to east, what is the sequence of all the cities? We have 4 cities. So going from west to east, if you recall, going from west to east, a sequence is city 1 first, then city 2, then city 3, then city 4. So the x-coordinate for city 1 is 1. If you go back, look at the map, the x-coordinate for city 2 is 2. The x-coordinate for city 3 is 3. The x-coordinate for city 4 is 4. It happened to be 1, 2, 3, 4. This is just coincidence. Now let's adding all the weights. So the sequence is going from 1, 2, 3, 4. If we only have 1 is the first city. So what is the weight for city 1? So weight for city 1 is 7. So we add 7 only. Okay, only add 7 because we want to keep, when we go from 1 to 4, we keep adding more and more weights. So right now we only have city 1. So total weight will be 7. 7 is the weight for city 1. So we have 7. So now let's check. Is 7 greater than or equal to 8? Of course not. If 7, the total weight currently, if you only include city 1, the total weight is 7. 7 is not greater than or equal to 8. So we have to keep adding more weights. We'll go to next city. The next city is 2. Now we need to calculate what is total weight for 1 and 2. For 1 and 2, it will be 7. 7 is the weight for 1, and then 1 is the weight for city 2. So 7 plus 1, which is 8. Now let's see, is 8 greater than or equal to the threshold, the median value 8? Is 8 greater than or equal to 8? Yes, because they are equal. Greater than or equal. Right? Greater than or equal. Yes, 8, the total weight 8 is greater than or equal to the median value 8. Then we can stop. We mark the last location. So what is the last location? The last location is location 2. Yeah, location 2, because at location 2, a total weight now reaches 8, which is the median value. So we stop. Okay, we mark location 2. This is last location. We mark it. We stop. Now we do a similar procedure, but we go in different direction. We go from east to west. If you are going from east to west, if you look at the previous map, you can see the order is city 4 first, then city 3, city 2, city 1. The x-coordinate for city 4 is 4. The x-coordinate for city 3 is 3. The x-coordinate for city 2 is 2. The x-coordinate for city 1 is 1. So let's keep adding all the weights. So first of all, look at the first location. So going from east to west, the first location, city 4. What's the weight for city 4? Which is 5. Okay, which is total. So total is 5. Is 5 greater than or equal to 8? The answer is no. If it's not, then we have to keep adding more weights. We'll go to the next location, which is 3. So 5 plus 3. 5 is a weight for city 4, and 3 is a weight for city 3. So what's the total weight? 5 plus 3, which we got 8. So is 8 greater than or equal to 8? So this is total weight. This is the median value. Is the total weight greater than or equal to median value? The answer is yes. Okay. Here, be careful. Equal is also fine. Okay. Greater than or equal to. So because 8 is greater than or equal to 8, we stop and we mark the lost location. So lost location is 3. Okay. So we went in 2 different directions. We basically check the total sum, make sure the total exceeds or equals the median value identified in step 1. Now, let's look at these 2 locations we just identified. So location 2 and location 3. Are they the same? Of course not. Location 2, location 3, they are not the same location. Okay, so that means now we have the x coordinator for the new facility. The x coordinator for the new facility should be anywhere between location 2 and the location 3. Okay, that's how we identify it. So because 2 and 3 are not the same, that means the x coordinator for the new facility should be anywhere between location 2 and the location 3. In other words, in terms of x coordinator, it should be between 2 and 3. The new facility should be built anywhere between x coordinator 2 and 3. So x coordinator should be between 2 and 3. Now we know the x coordinator value for the new facility. Now we go to step 3. Step 3 is about identify the y coordinator for the new facility. So we're going to do a similar procedure. We're going in 2 different directions. First of all, let's go from north to south. Going from north to south, what is the sequence of all 4 cities? If you recall, the sequence is city 3 first, then city 2, and city 1, and city 4. That's the sequence. If you don't remember, you can go back and look at the map. Then we also want to identify the y coordinator for each location. So the y coordinator for city 3 is 5. The y coordinator for city 2 is 3. The y coordinator for city 1 is 2, and the y coordinator for city 4 is 1. Now let's keep adding all the weights. Let's look at first city, which is city 3. So what's the weight for city 3, which is 3? So is 3 greater than or equal to the median value, which is 8? Of course not. If it's not, then we have to keep adding more weights. So we'll have to add the weights for city 2 as well. So 3 plus the weight for city 2, which is 1. So the weight for city 2 is 1. If you don't remember, you can go back, look at the map. So which is 4? Is 4 greater than or equal to 8? Of course, the answer is no. If not, we'll have to keep adding more weights. So currently, with 2 cities, okay, with city 3 and 2, the total weight is 4, which is not enough, okay, to hit the median value. So we have to keep adding one more city, which is city 1. So what's the total weight? With another city, city 1, the weight for city 1 is 7. So 4, which is total weight for 3 and 2, plus 7, which is the weight for 1. Now we have a value of 11. Is 11 greater than or equal to 8? The answer is yes. If it's a yes, we can stop. Now we mark the last location, which is city 1. Similarly, we can do the other direction. So we're going from south to north. So if you recall, the sequence from south to north is basically opposite. Okay, the opposite. The first city, if you're going from south to north, the first city is 4, and then 1, then 2, and then 3. So what is the y coordinator for 4 different cities? So the y coordinator for city 4 is 1. The y coordinator for city 1 is 2. The y coordinator for city 2 is 3. The y coordinator for city 3 is 5. And we keep adding all the weights. So first of all, let's look at the first city, which is city 4. So what is the weight for city 4? It's 5. So is 5 greater than or equal to 8? Of course, the answer is no. That means we have to keep adding more cities. The next city was 1, okay, city 1. So what's the weight for city 1? The weight for city 1, if you check at the map, it's 7. So we'll have 5, which is the weight for city 4, plus 7, which is the weight for city 1. Now we have a total of 12. The total weight is 12. Is 12 greater than or equal to 8? The answer, of course, is yes. So if that's the case, we can stop. We mark the last location. So last location is 1. So look at here. We mark two locations going in 2 different directions. Are they the same? 1 and a 1? Yes, they basically are the same location. Okay, if they are the same location, basically means the y coordinator for the new facility should be equal to the y coordinator for this location, the location 1. So the y coordinator for the new facility should be equal to the y coordinator for location 1, which is 2, which is 2. So the y coordinator should be 2. So from step 2, we know for the new facility, the x coordinator should be between 2 and 3, and for the y coordinator it should be 2. So what does that mean? We go to the next map, we try to identify the location for the new facility. First of all, we know for the new facility, the x coordinator, if you look at x coordinator, the horizontal dimension, it should be between 2 and 3. And that means anywhere between 2 and 3. Somewhere from here to here. It should be anywhere between 2 and 3. Can be anywhere here, 2 and 3, but not above 3, not below 2. Okay, anywhere between 2 and 3. This is the x dimension. What is the y dimension? If you recall from step 3, the y coordinator for the new facility should be equal to 2. So 2 is right here. It should be equal to 2. That means it should be right here. It should be always 2. Exactly 2. So y should be exactly 2. The x can be anywhere between 2 and 3. What does that mean? What does that mean is the new facility should be anywhere from point A to point B. It's a line segment because this line segment basically represents all possible locations with a y coordinate of 2 and with the x coordinate between 2 and 3. So x is between 2 and 3, y should be exactly 2. So this green line segment basically indicates all the possible locations for the new facility. So you can choose anywhere between A and B. That is optimal solution.